Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. Intel lost $18.8 billion in a single year and was forced to cancel development of its next-generation 1.4nm chip. NVIDIA's castrated H20 chips, customized for China, sat unused in warehouses. TSMC spent 4 years building its US factory, yet failed to produce a single chip. When the US launched its chip blockade 3 years ago, no one imagined the outcome would be this, that it would be the company eliminated. In 2024, Intel delivered a financial report that left Wall Street speechless. A full-year loss of $18.8 billion, the highest in the company's 56-year history. The direct trigger for the massive deficit was export controls that cut off its largest source of profit, the Chinese market. In 2019, Intel earned $20 billion in China, accounting for 28% of its global revenue. By 2024, despite revenue shrinking to $15.5 billion, its share had risen to 29%. This was because other global markets were collapsing even faster. To survive, newly appointed CEO Lip-Mo Chen executed 3 major cuts within 3 months, selling a subsidiary, laying off 15,000 employees, and shutting down the cutting-edge process R&D team. The once highly anticipated 1.4nm project was frozen, and the high-NA EUV lithography machines, ordered at high prices from TSMC, became scrap metal in the warehouse. Meanwhile, TSMC and Samsung's 2nm production lines were operating at full speed. The US chip manufacturing revival plan was ended by its own top player. The ignominious exit of the castrated chip. When the US government banned NVIDIA from selling high-end AI chips to China, Jensen Huang came up with a China-friendly solution, releasing a special version of the H20 with 30% reduced performance. He assumed Chinese companies would accept it, believing, after all, you have no choice but NVIDIA. Reality slapped him in the face. In May 2025, the Cyberspace Administration of China summoned NVIDIA and demanded an explanation of the security vulnerabilities in the H20 chip. This wasn't a technical inquiry, but a pronouncement of attitude. The computing power of domestic AI chips has surpassed that of the H20. Huawei's Ascend 910B achieved a 300% increase in efficiency in inference tasks, and the Cambrian Siyuan 590 chip saw a 42-fold increase in annual revenue. Huang Renshuan visited China 3 times to promote the product, but received only a cold reception. 3 months later, H20 production was officially discontinued, and NVIDIA completely withdrew from the Chinese market. American companies suddenly discovered they were no longer facing a China that couldn't afford high-end chips, but one that despised castrated technology. It's not that they can't afford it, it's that they simply don't want to buy it. A CNN headline captured the collective predicament of American chipmakers. The curse of unfinished American factories. The current state of TSMC's Arizona factory has become a satirical example of the rationing of American manufacturing. Originally scheduled to begin production in 2024, mass production has been delayed until 2027 due to workers' inability to install lithography machines and plumbers protesting Taiwanese engineers taking their jobs. Even if it were to begin production, its production capacity would only be enough to meet 7% of US chip demand. Even more absurd is the cost. AMD's internal report shows that chip costs in US factories are 5% to 20% higher than in Taiwan. TSMC founder Morris Chang publicly admitted, chip production in Arizona costs 1.5 times more than in Taiwan. Government subsidies can't fill this gap. Unions are demanding a 30% wage increase, environmental inspections are slowing construction, and even plumbing installation is taking 8 extra months. Biden's promised $39 billion in chip subsidies have so far delivered less than 30% of them. While the US is stuck in advanced manufacturing processes, China is choosing to bypass them and overtake. Shanghai Microelectronics' 28nm lithography machine has passed production line verification, and the 14nm model is entering the installation phase. The nano-imprint lithography equipment developed by the Chinese Academy of Sciences has achieved a breakthrough in 10nm process technology, costing only 1/5 the cost of an EUV lithography machine. Zhejiang University's electron beam lithography machine has matched ASML's second-generation EUV in precision and is currently being tested on Huawei's RF chip production line. Mature processes have become the main battleground. Yangtze Memory Technology's 232-layer flash memory chips rival Samsung's performance, while SMIC's 14nm yield reaches 90%, and its cost is 20% lower than the international average. By 2025, China's monthly 12-inch wafer production capacity will reach 2.4 million wafers, accounting for 42% of the global market share. Will the US ban HBM memory chips? China's DRAM production capacity has risen to 250,000 wafers per month, pushing its global share to 10%. Even the technology roadmap is being restructured. The Chinese Academy of Sciences integrated storage and computing chip improves AI inference energy efficiency by 10x, while Tsinghua University's model compression technology reduces computing power requirements by 30%. RISC-V architecture chip shipments are expected to exceed 5 billion by 2025 and will account for 30% of the global market by 2030. Microsoft Windows pre-installation rate in China has fallen below 40%, while the Tongshan UOS operating system is now plug-and-play. Domestic computers that required drivers 5 years ago can now be used directly by even the elderly. Beijing taxi drivers have discovered that their newly purchased BYD electric cars charge faster, thanks to silicon carbide components that boost the efficiency of the 800V high-voltage platform by 20%. Shanghai white-collar workers are buying domestic computers pre-installed with the Hongmeng operating system, which boots up 4 seconds faster than Windows. Quality inspectors at Shenzhen factories are using domestic AI cameras to identify defects, using only 1/10 the power consumption of imported equipment. Government procurement lists are a bellwether. The 3 major carriers have received a strict order to completely replace foreign chips in their core networks by 2027. The Ministry of Finance's bidding documents list Lungsan computers, Huawei printers, and Yangtze memory hard drives as standard equipment. The names of Intel and AMD are disappearing from billboards in computer malls across China. Across the ocean in Phoenix, American workers at TSMC's factory are arguing with Taiwanese supervisors over whether to wear cleanroom suits. Intel's Ohio factory faces a mountain of approval documents, pushing its start date from 2026 to 2030. ASML stock plummeted 13% in 2025 after China launched a security review of imported lithography machines, demanding the disclosure of sensitive parameters, or a sales ban. This war, which began with a technological blockade, has its end written in unfinished construction sites in Arizona, in the computing power curves of Huawei's Ascend chips, and in SMIC's fully operational wafer production lines. When Chinese engineers attached photos of 1956 hand-cranked calculators to the casings of domestically produced lithography machines, the balance of power for silicon-based supremacy had already tilted.